screencast for section 5.2, example 3. We're going to do some more proofs. We're going to identify and prove an identity, but you don't know what this actually equals first. So ahead of time, I graphed f of x equals 1 over the secant of x minus 1 plus 1 over the secant of x plus 1 in y1 of my calculator, and then I graphed this in y2 and this in y3 and found out which one actually does equal. In other words, which one graphs the same. Again, remember to be in radian mode. So I've already figured out that the original function equals 2 cotangent of x cosecant of x. So I set up those to be equal, and now I have to choose which side to start with first. The left side to me seems a little bit more simple, so I'm going to start with the right side that seems a little bit more complicated. Plus, I know how to find a common denominator, so that gives me a good algebraic first move to make, and that is what I'm going to do. I see that I have secant of x minus 1 and secant of x plus 1, so if I do make a common denominator, I'll have a difference of squares as my common denominator. Secant of x minus 1, secant of x plus 1. So this guy needs a secant of x plus 1. The second guy already has a secant of x plus 1, so it needs a secant of x minus 1. Now I have in the numerator secant of x plus 1 all over what's going to be my common denominator, secant squared x minus 1, because a minus b times a plus b is a squared minus b squared, a difference of squares. Secant of x minus 1 in the second fraction here, second term, also common denominator of secant squared x minus 1. Now since I have a common denominator, I can combine those numerators. Secant of x plus 1 plus the secant of x minus 1. I don't need parentheses around that because I'm just adding it, so I don't have anything to distribute where parentheses would make a difference. Now, secant plus secant is 2 secant, and then 1 minus 1 is 0. So now I'm going to kind of start back up over here. I have 2 secant of x, and that's it in the numerator, over secant squared of x minus 1. Now I know from my Pythagorean identities that secant squared x minus 1 is tangent squared. So 2 times the secant of x over tangent squared of x will be my next step. But I can't leave this as secant divided by tangent squared of x. I need to leave it as a, because my goal is cotangent of x times cosecant of x. So in order to see how these line up together, I'm going to change everything to sines and cosines. So I'm going to put my 2 off to the side, and I'm going to take secant of x and change that to 1 over cosine of x, and tangent squared of x to be sine squared of x over cosine squared of x. Now instead of dividing by fractions, I'm going to multiply by the reciprocal. So I have 1 over cosine of x times, this will be cosine squared of x over sine squared of x. Now since I need the left side to be 2 times cotangent of x times cosecant of x, I'm going to say this is 2 times, I know cotangent is cosine of x over sine of x, which I will have a cosine in the numerator after I cancel those 2 out. And then I will have a sine of x left in the denominator. I've used one of the sine of x's in the denominator, but I need to use the other one. And this does in fact equal 2 times the cotangent of x cosecant of x. So I rearranged all of this stuff to make sure that I have the left side to be exactly like the right side. 2 cotangent of x cosecant of x. The now try problem is number 55. Same kind of setup. They give you an original function and you have to determine which one is equivalent. So I graphed number 55 in y1, and then I tried each of those in a different y and found out that 2 secant squared of x has the same graph as 1 over 1 plus sine of x plus 1 over 1 minus sine of x. Again, it's a very similar situation to the example. I see a, not necessarily a common denominator, but I do see a potential to have a common denominator. So I'm going to get that common denominator, 1 plus sine of x, and the common denominator will be a difference of squares. Getting ahead of myself here. The 1 plus sine of x needs a 1 minus sine of x. And the term with 1 minus sine of x in the denominator needs a 1 plus sine of x. Make sure to have my equal sign because I'm working with the left side only. Now I have 1 minus sine of x plus 1 plus sine of x, all in the numerator. In the denominator I will have 1 minus sine squared of x, that difference of squares common denominator. So in the numerator, 1 plus 1 is 2. Oh, and then the denominator, this negative sign and positive sign will cancel, so all I have in the denominator is 1 minus sine squared of x, which is cosine squared of x. So that's really 2 times 1 over cosine squared of x, which is 2 secant squared of x. Exactly what I was hoping.